Hi class, so we're going to continue with the transformation unit. So if I write the general form of a transform function again, okay, there's the general form. And just as a reminder, the order in which we transform will be compressions, stretches, reflections, which are in the A and the K value, and then we'll look at the shifts, up or down or left or right. So this is left and right, and up and down. So here we've got what we're going to do on the left side of the graph is draw the original coordinates. So we see the A is at -3 and 1. That's why we have -3, 1 here. And if we're to transform that point, you can see that the x is staying as the original coordinate, and the y, or the f of x, is simply being shifted up 4 units. So that's why we add 4 to the 1. Now if we write the other original A coordinates, so the next one would be -2, -2. The next coordinate, oh, that's not A, it's B. The next coordinate C is 1, -1. Remember, x is first, y is second, and then finally the D coordinate, you would have 3 and -1. And now what you want to do when you transform them, the x coordinates will always stay the same because we're only transforming the y value by 4 units up. So we have B, -2, 2, C, 1, 3, and what is your D value? So here actually we would write, let's say, they use just a notation like this little tick to show it's transformed, to show it's different from the original value. And then the transformed D value would be again 3, 3. Now what you want to do is, you should pause the video and then try to plot the new points. So for example, -2, 2, -3, and then 5. So this is your new transformed A point. And then your B would be -2, 2. Okay, so pause the video and plot it. I will do the same. Alright, so you should compare your graph to the graph I drew here. And it's simply the same shape, but shifted upwards 4 units. That's why we have the +4. Now for the next section of this lesson, we're going to concentrate on the quadratic function and transforming it. So first thing you need to get comfortable with is plotting the base function, or what we call the parent function. So that is equal to f of x of a quadratic is simply x squared. And if we compare that to the transformed function, a times f of, you should get comfortable writing this out, x minus d plus c. In all these cases, the original function, your a value is 1, that's why you don't see it. Your k value is 1, you don't see it. And then your d and c values are zeros. And again, fill in the table of values, so we've got -3, -2. Well, why do we use these values again? Because we know that the parent function is centered around 0. It's a parabola. So 9, 4, 1. And you can always pause the video to fill in the values yourself. And if you want to plot it, or you should plot it, we've got, if I start in the middle here, 0, 0, 1, 1, -1, 1, 1, 1, -2, 4, 2, 4, 3, 9, negative 3, 9, and 3, 9. And then you want to join the points. Okay, so here you've got your parabola. And don't forget, when you're graphing, you should label the axis as well. The scale's already there, so you don't need to worry about that. And as a reminder as well, when you're the order of reflections would be stretches, compressions, reflections, which are your A and your K values, and translations, which are your D and C values. So you would have A, K, D, C. And then we'll show examples of this on the following pages. Alright, so this next section has two parts to it. Describe the changes and write the transform function. So if we say g of x equals 2 times f of x, and our f of x is the base function or the parent function for the quadratic, f of x equals x squared. So when we have g of x equals 2 f of x, which part of that general equation is this? So as a reminder, when the number, the value is outside the original function, that's your a value. So since a is greater than 2, we say this is a vertical stretch by a factor of 2. And that means the original, the transform function, g of x, is simply a times the original function, where the original function is x squared. So a times x squared. Not a. We have a value for a. A is 2. Oops. There you go. And if we relate this to this next transform function, where's this 2 now? We can see this 2 is our k value, or this one was our a value. And the difference here is when the k value is inside the bracket, when the value is inside the bracket, we now say this is a horizontal, so it's affecting the x value, horizontal compression by a factor of 1 over 2. And our transformed function will then be g of x is going to be equal to now 2x all squared, where remember this is our parent function. So we're taking the original x and we're multiplying it by 2. So that whole value gets squared. And now here, when we have g of x equals fx plus 4, which part of the 4 is this function? That's correct. It's the c. So that means it's going to be a shift up or down. And since it's plus 4, we say that we're going to shift up 4 units of the original y values. So remember, the a and the c affect the y values. So that would mean our new transform function, g of x, would be the original function, which is x squared, plus 4. So here I'll just write c equals 4. Here your a equals 2. Here your k equals 2. Now this value, you can see is your d value. So we would say now since this is positive and the original formula is negative, that means your d is actually negative 3. And then again, that affects the original x value. So we're going to shift to the left 3 units. Shift left 3 units. So the transform function g of x would now be x plus 3 squared. All right, so the next one, we've got here negative f of x, which means our a value, this is our a value, is actually negative 1. So it's good when you're looking at the functions if you can identify whether it's a, k, d, or c. So here, what this means is we've got a reflection through the x-axis. So all the original y values are essentially multiplied by negative 1. Well, they are. Reflection through the y. No, the x-axis. And if we were to write the transform function, then we have g of x will be equal to negative x squared. And then finally here, when we have the negative sign inside, that means our k is equal to negative 1. And that's now a reflection through the y-axis. And the way we would write that transform function, we would have g of x is equal to negative x squared. Great. I'm going to pause and start a new video for the next part.